Hello everyone. I hope the situation is fair. We know the lockdown, but please keep safe. Don't just move. Move for a reason in order to keep your life safe until we meet again. This is Kiwalabye Jojo William, Trinity College Nabingo. We are going to look at the climate of Africa. I believe that in your East Africa, you must have looked at the types of climate of Africa and so on. So we shall be actually borrowing knowledge from East Africa, and we see that we can understand this concept of the rest of Africa. As you know, from the definition of climate, you must have seen what we call the elements of weather. So climate is just a condition of the atmosphere that is determined for a long period of time. So which means that someone must have looked at the elements of weather, for example, rainfall, temperature, humidity, cloudy cover, atmospheric pressure, speed of wind, strength of wind, etc., to come up with climate of an area or a region. So we actually look at the summation in around between 30 to 35 years. That's when somebody can actually describe the climate of an area or a region. So in our discussion, we shall be actually pointing at elements of weather, most especially rainfall and temperature. So we see that the climatic zones of Africa are actually expressed in terms of their elements, in terms of the elements of weather as listed below. In order to describe climate of an area, you must have observed it and measured those elements of weather for a long period of time, as I've said in our previous slide, 30 to 35 years. So it is actually a long-term condition. So you cannot just live in an area for a week and you say, this is the climate of this area. So you must have observed those elements of weather. When you come to Africa, Africa has varied climatic zones which are attributed to the factors that we are going to discuss in our next slides. So we can see that in Africa there is a variation in terms of climate. So you find that an area or a region experiences warm or hot and wet conditions. Then another one experiences very hot and dry conditions. So these are the factors that we are going to discuss in our next slides. We are going to begin with altitude. So this is just the height above sea level, height of land above sea level, whereby we look at the temperature varying with the altitude. That when you climb or when you experience a climb, the temperature reduces basing on the height. So we see that in this factor of altitude, we look at the situation where temperature lowers with an increase in altitude. So this is called lapse rate. That is lapse rate. Yes, in our images on the left, you can actually see that at a lower altitude, our temperature is 23.5 degrees. That is at 1,000 meters. Then in the middle slopes, or along the middle slopes, you can see our temperature is 17 degrees Celsius. That is at 2000 meters above sea level. So this means that our temperature has reduced by 6.5 degrees Celsius. So in a normal situation, we can see that temperature reduces by 6.5 degrees Celsius as you ascend 1000 kilometers. So we can see that at the top, or almost at the peak of this mountain, where you see the white material that represents ice, our temperature is 3000 meters. Sorry, our degrees are actually almost 10.5. Yes. So as the altitude increases, the temperature reduces up to 0, up to negative, and on our right, we see the top or the peak of a certain mountain, where we see the ice crystals. So we can see that in our conclusion about this point, we see that lower slopes experience hot temperature and the upper slopes experience cool and cold temperature, that is altitude. We move to latitude. This is angular distance of a place from the equator, whereby in our image on the left, we actually compare the sun's rays and the globe. The globe is representing the Earth. So we see that the equator is near the sun, so which means that it experiences high amount of sun rays compared to the high latitude areas. So this implies that areas near the equator experience hot temperature compared to the high latitude areas. So which means that the seasons here, we have the dry and a wet season, that is along the equator. But when you move to the higher latitudes, that is beyond 45, we shall actually see that they experience winter and summer basing on the apparent movement of the sun. So we see that the hot temperature also raises what we call evaporation, and in our right image, we see that areas near the equator on the map of Africa, where we have green, experience or receive heavy rainfall and experience hot temperature. We move to relief. This is the nature of landscape. So we have highland areas receive heavy rainfall, which is in terms of relief on the windward slopes due to the moist ascending wind. So ascending wind picks moisture from a source region. That source region may be of a large forest, or it can be a large water body like an ocean, a lake, or a large swamp. So whenever it as this wind picks moisture, it actually finds the barrier, which is a mountain. It is forced to rise with its moisture, and on reaching the condensation level, that moisture condenses and forms water vapor, which turns into clouds that will produce rainfall on the windward slopes. So in our image on your left, that is bottom left, you can see this side of the mountain where everything is green, so which means that there is heavy rainfall which is being received. Then however, we see that on your right, that is the leeward slope, wind having lost moisture on the windward slopes, it actually descends, and when it descends, it is already dry, so which brings about dry conditions on the leeward side. So on the bottom right, you can see the dry surface, implying that this area receives little and unreliable rainfall because it actually is found on the what? On the rain shadow. So on the rain shadow, in the rain shadow, yeah, due to the descending wind. So an example can be the southern slopes of the Ethiopian islands, where wind actually picks moisture from the Red Sea and releases it to the windward slopes of the Ethiopian mountains or highlands. Then we can see rainfall that side. Then this side of the southern part receives or experiences what we call dry winds. We move to ocean currents. These are actually drifts or movements of the ocean waters in a specific direction. So in Africa, we have several ocean currents. We can talk about the Mozambique ocean currents, or you can call them the Agulhas currents, which are actually warm. They are warm because they originate from the equator and moving into the direction of the polar region, that is southwards. So they actually wash the eastern coast in the areas like Durban, that is the southeastern coast in South Africa. So they raise temperature, and that temperature results into what we call evaporation, which later brings about rainfall. So for that case, we see that the coastal areas which are washed by the Agulhas, that is Mozambique ocean current, experience hot temperature and heavy rainfall. However, we have another category of ocean currents, that is the Canary, Cool, and the Benguela ocean currents. The Canary originate from the North Pole to the direction of the equator. That is, they wash the northwestern part of Africa in the countries like Mauritania, Morocco, then towards the western part to actually change the climate of Senegal. Then likewise, Benguela originates from the Antarctica towards the equator, and then they actually come when they are cool and wash the coastal areas of part of South Africa and Namibia. So they lead to the formation of Namib Desert. Yes, we can see in our image on the left, upper left, we see the movement of the ocean currents, then the effect, that is bottom left. So we see that the cool ocean currents bring about desert conditions. So what you see is the Namib Desert. Then on our right, the Agulhas warm ocean currents actually bring about hot and wet conditions. So we see this part of South Africa along the coast, that is in Durban. So we can see green, meaning that the area receives heavy rainfall. Prevailing winds. We can see that Africa lies in the path of trade winds. For example, the northeast trade winds. So these ones originate from the dry conditions. Actually, for a trade wind to determine the climate of an area or a region, it actually depends on the source region or where it originates from. So this is like an air mass that originates from the dry condition, and it comes with little or very little moisture or no moisture, and it actually brings about the dry conditions in countries like Somalia. Then we come to the southeast trade winds. These ones originate from the Indian Ocean and the Atlantic Ocean. So we see that these ones come with a lot of moisture and bring about rainfall. So we can see how they actually move from their source regions to their destinations. Then we look at the ITCZ, that is the Intertropical Convergence Zone. So this is actually the point, or it is called a front, where these winds, the northeast and southeast trade winds, meet or they converge. And when they converge, they form a line which is known as a front. And we can see that they bring about rainfall basing on where the front has been formed. So we can see that the ITCZ moves basing on the apparent movement of the sun. That when the sun moves to the north, actually when we look at Africa, we see that it's the extremity of movement. Sorry, the movement of the sun. We look at it in terms of the Tropic of Cancer. So that Tropic of Cancer, we shall actually experience, or we shall see that that's where the northeast trade winds will meet the southeast trade winds, and they form a front that results into rainfall which is received during the middle months of the year. Likewise, in the southern part, when the sun moves to the south, apparently, we use the word apparently because it's not the sun that moves, it is the earth which rotates. Yes, towards the end of the year, the sun moves to the south and overheads the Tropic of Capricorn. So we can see that that's where our ITCZ will actually be, and it will lead to formation of rainfall. However, the ITCZ most concentrates on the equator, or areas around the equator, because we can see that's where there is a lot of warm rising air, and that results into rainfall, into two seasons of rainfall, which are received by the West African countries and the countries of the central, like Congo, Gabon, and other countries like Central African Republic. In our conclusion, we have actually looked at majorly the factors affecting climate of Africa, and we expect in our next lesson to look at the climatic zones. So we are actually going to differentiate or distinguish the different climatic zones, and we shall see their characteristics and even the activities or the effect of such zones on land use. Thank you so much. I wish you well, and please, for more information, you can tap on the link below to actually download whatever you want in terms of studies. Thank you so much. God bless.